So, welcome. Today, we're talking about product development. This is a topic that most of you already understand really well because the great majority of you have been working most of your careers in product development. So, there is less novelty than when I talk about life in a sales organization or the life of finance and administration, where on average, you don't have as much direct experience. And so I'll walk into this with a little bit of care, but I think there are key aspects of product development in a startup environment which are different. And it's worth highlighting them if you haven't been part of that environment. It is part of the larger story of the exploration to find product market fit because clearly a big engine within that discovery of product market fit is the exploration that happens on the product side, the rapid innovation that has to take place as you're inside that close feedback loop of figuring out what is the proper overlap between what you know how to build and what customers really want and need. So at the core of it is really this idea that you are making a set of choices here. You're choosing what aspects of your idea and the skills of the team and the currently available technologies that you're going to leverage. And usually you have a pretty broad portfolio of choices because you typically will have a bunch of smart people who have rich experiences and who are both knowledgeable about technologies in the past and excited about pushing the envelope of technologies going forward. So that you are making a large number of choices, particularly in the early days, and choices that you may get to live with if you're successful or have to live with over a period of years going forward. And so choosing carefully is important. But at the same time, you have to move fast. So you not only have to choose carefully, but often choose relatively quickly without sufficient information because you're balancing how feasible something is, how comfortable it is for you, and how differentiated it is. And differentiated sometimes comes down to few, if any, people have ever done this before. You want to build what you know, but at the same time, build something which is going to be genuinely new in the eyes of the customers, new in a comfortable way. And you're often choosing what form of matter your product is going to be. Now, especially in things related to deep tech, you're going to have many possible combinations of hardware and software. In the classic tech startup, which these days is kind of 90% software, you don't have that trade-off, but you may have similar trade-offs of edge versus cloud, AI versus conventional algorithms. There are always macro scale choices that you face around which major themes and which skill sets you're going to leverage, what skill sets you're going to require. And when we talk about product development, we also are talking about the internal mechanisms. What are the phases that you go through as an organization, the phases that you go through in product development? Who plays what kind of role? What is the necessary coverage of roles that you need to have, both in the development of product one, which is often the most straightforward part, but then products two, three, and four, which require increasing levels of discipline and scalability and attention to controls and quality, where you may be able to think minimum viable product in the first generation, but end customers don't want minimum products. They want products that are robust in many ways that are well thought out. And product development is generally the biggest and most complex process that's taking place in a company. And so it often requires the greatest discipline around requirements and timelines and deliverables. And so there is a need for structure in how you think about the problem in ways that are often somewhat different from how you might approach marketing or selling along the way. So you're on the horns of multiple dilemmas that you are balancing innovation and completeness. You're balancing timeliness and quality. All of those things, you have to make hard choices sometimes about where the real emphasis is, depending on what phase you're at in that development process. So in the early days, you're building really for two purposes. One, you're building something to use to connect with customers, to find something that allows you to find your place in their lives. At the same time, you're also building so that you can learn about your own idea. If you knew everything about what it took to build some, fabulous new AI model, or you knew everything that it took to build some new kind of user interface, you wouldn't be pushing the envelope. You wouldn't be differentiating yourself. And so part of what's going on is that you're training yourself. You, your team, are learning about the limits of that technology. And as you do that, you can really think about pushing the envelope on building fast enough to learn as much as possible, but without breaking what matters, without going past what is feasible and creating something that is untenable as a product or is unworkable when put into a customer environment. So we're going to talk first about how the fundamental cycles of idea to product work. And a lot of this is by prototyping. Now, and there's this interesting trade-off that a lot of what you're going to learn from customers. And so the purpose of product development is to have good conversations with customers in the early days. And part of it is something you're going to learn by doing. You're going to learn by building and figuring out what is feasible and what is not. And these two cycles of building just enough to be able to engage with early customers and building just enough in order to learn what the technology will allow are constantly interacting in the early days of a startup. And we can think about the classical development process as having as its foundation this essential refinement theme. You start with vague ideas, you test feasibility, you come up with target specifications and feature lists, you develop, you release, you support that product. But a lot of what's going on is creating the insights, both from customers and from your own technical work, that allows you to feedback and try again. And so you have many feedback loops, but it's worth simplifying it into two pieces of feedback. One, you have the very fast feedback that comes from a prototype, something that is not a complete product. It's something which is just good enough to teach you something about the direct feasibility of a technology, and just enough that you can have a conversation with a customer. And then you're also getting ready for the long term, where in fact you should, to a significant degree, assume success, assume that you're going to have customers, such that when you really deliver, that first product, it's good enough, it's complete enough that customers will have a satisfying experience. They will start to commit the fundamental workflows of their own company, their own operations, their own engineering, their own sales process around the existence of your technology, such that they will then be wanting upgrades. They will be wanting new features. They will be wanting major new generations. Or you will be going from that first narrow set of customers to a broader set of customers, and you will build new generations of product to fulfill those broader or different customer requirements. And so you have this fully baked product cycle as well, which is taking place at the same time. And in the early days, you have to be thinking a little bit about both how you're going to change that prototype and how you're going to turn that prototype into a whole product, a robust product. So there are kind of classic phases or dimensions of that product, and you can sort of think about it as, basic understanding of what is the set of functions you're going to deliver and when are you going to do it. What are you going to do in the core development, which may be designing hardware. It certainly will be writing software. It will be working with third parties on leveraging interfaces that allow you to do new things. And then there's all the less glamorous hard work associated with testing and documentation and support and development of supporting tooling to make it happen. Of course, when people think about engineering, they often are thinking about the most obvious pieces. In 1 and 2, you're doing architecture and you're writing a lot of code, but that really represents a relatively modest fraction of the total engineering effort, as you well know. I mean, in chip design, for example, it's sort of commonly understood that 3/4 of the hardware development effort is in testing and verification. And a lot of the same carries over even into pure software development, where making the rest of this work such that it is both a usable product and a sustainable product requires a great deal of attention on the less sexy. Some would view it the less creative part, but it's certainly a necessary part of it. And it's really interesting to rethink this in the light of AI software development, because AI software tools will do a lot of good things. Certainly, they can produce volumes of documentation that would daunt the ordinary documenter. But perhaps the biggest impact of AI software tools as they exist today is that they love to write code and they can produce masses of code. I recently went through this vibe coding experience, building a relatively large application from scratch by myself with the ground rule that I was never once going to look at the actual code generated, only at the behavior of it. And the tool wrote effectively hundreds of thousands of lines of code as part of various experiments, of which at the end of the day, 40 or 50,000 lines of code became part of the initial release, if you will. It wasn't really a product. It was really a rapid prototype, but the code generation speed and ease were extraordinary. The code generation accuracy was not necessarily very high. It was also pretty good at writing documentation. The tool loved to write documentation. I think over the course of an 8-week project, it wrote 100,000 lines of documentation describing in English prose what it was trying to do at various points along the way. I don't think it ever once read any of its own documentation. It was so much like a human developer a junior human developer, when asked to write documentation, writes documentation. But the uh, apparent unwillingness of AI software tools to actually do the necessary structured thinking about the big picture is much less apparent. So there's a very interesting human computing parallels between how this list is approached uh, by people and how it's approached by AI. So what are the major activities in development? Of course, these are the classic things we think about. The architecture, the design, the selection of a structure that's going to be used, whether you're doing a microprocessor or you're designing a router box or you're thinking about an online marketplace or you're designing a new AI model. You're going to think a lot about architecture and structure and principles first, and then you're going to do implementation of it. And what's really important is to remember how much of the other pieces are going to play a significant role in it. How are you going to test it? What are the mechanisms for security? And increasingly, both hardware and software products need to think closely about security because almost any information technology product presents some attack surface for some bad actor to disrupt the use of the product. For usability as a whole product, you're going to actually have to think a lot about what's the installation, configuration, migration, and support of that product. What are the mechanisms for extensibility? How are people going to use this as a building block inside of some larger project, which may be literally hardware extensibility in the style of Tensilica's instruction set extensibility, where you really were adding hundreds of thousands of gates of logic to the hardware design, or APIs where other software is written to exploit the available services. You're also going to be thinking a lot about how this integrates from a user perspective into the workflows and operations of your customer, and how that customer is going to adapt it. How are you going to adapt it to changing needs of the customer, or how is the customer going to adapt it to actually make it work? Because very rarely does a product work exactly as the customer wants or the customer needs out of the box. And so there is always a process of fitting to make sure that happens. And a lot of the utility of the product comes from that adaptability, which is a reflection both on the way the product is built, and it's a reflection on the organization that built it, such that they are able to robustly change the product as customer requirements need. Now, as we talked about when we were talking about revenue recognition last time, it's not as if you can afford to leave the door open to say that we will continuously rebuild the product for the same price as you go forward. But you do have an opportunity to build subsequent generations of the product with new features, or to include features in the baseline product that allow the customer to adapt it without a great deal of further work on your part. But thinking about the evolution of the product is almost as important, and sometimes more important, than thinking about how perfect it was in its initial instance. And then around all of that, you have what's critically important, which is your own development infrastructure. What is it that you put in place in terms of tools, in terms of internal collaboration, expectations, in terms of data sets, in terms of computing resources that allowed you to do all these different things in a reasonably well organized fashion. Now, of course, in the early days of a startup, you're probably pretty minimal, and that's okay. You're not doing an enormous amount of development in absolute terms, and you certainly don't have much legacy that you're trying to support. And one of the critical questions in the early days is how much infrastructure is enough? There is sometimes a temptation, especially for people that come from large organizations, is to say, well, okay, at day one, we need all of these highly automated systems, and we need to have big company infrastructure for database management, for bug reporting, for regression testing. And you certainly need some of all of that. But you have to figure out how you're going to grow that in tandem with growing the product, because there is a relationship between the right infrastructure and the type of product that you're building. And while you're still in the process of discovery of what your product is, you don't want to be something in a position where you're constrained by the servicing of an infrastructure which is not the right infrastructure for the kind of product that you're building. And so there's always a key creative aspect here, that especially as you're building something that's really new, something that's really fresh, you get to think through what is the infrastructure that makes sense in the new world that you're building, rather than what was the infrastructure when you were building last year's product, which was leveraging probably 5-year-old infrastructure back at your big company. It's opportunity, but it's also a requirement to gradually create that infrastructure that is most appropriate for what you're building.